Swayam Prabha. Digital India. Educated India.
Hello and welcome back. So in this video, we are going to look at contrast enhancement technique. So contrast enhancement is basically a form of image enhancement, and it's one of the most simple operations that is used in medical image analysis. Okay, and this is primarily done to improve the identification of a particular features in an image, basically to make something appear more bright or more distinctive from the background. Okay. So we call it contrast enhancement because contrast, if you want to define contrast, it's basically how different it is from the background. Okay. And it's also, contrast enhancement, noise enhancement together, noise reduction together, in combination with, like I mentioned earlier, emphasis of different structures on the image. Okay. So we had also mentioned earlier, we'll just look at the formulation of these techniques, and I will show the results in a separate class. So the idea behind this method is to have, for every pixel in an image F, you have to find a new value G through a linear mapping. Okay, so it's a linear transformation. Not necessarily a linear transformation, I'll say linear mapping. And typically what you do is you want to map all the pixel values in F to a range between Imax and Imin. So this Imax and Imin is chosen by the user, typically a clinician or radiologist who in his experience knows the best Imax and Imin. Okay. This process is also called adjusting the window and level, primarily because you can choose a level L, and from there you can go W over 2 to the right, W over 2 to the left. So which means you will be mapping between L minus W over 2 to L plus W over 2. So let's see how it's actually done. So the formula, I'll write this down, is G of F, that's the transformed intensity, is equal to F minus F min. We have Imax minus Imin divided by F max minus F min plus Imin. Okay. So this G is often called the transfer function. Okay. So you can actually see that if you plug in the appropriate values, you will get the desired result. So for instance, when F, you can try to see when F is equal to F min and F is equal to F max, then the G then goes to I min, and in this case G goes to I max. You can just plug the values in here and then verify that. Now here what you are doing is taking every pixel value in F. Of course we are identifying the minimum and the maximum values in F and denote them as F max and F min, and then you are trying to do a linear mapping. So you think of this expression here as estimating the slope. Okay, so you're doing a linear fit, just estimating a slope here, and then you're just using a straight line fit to go from F to G. Okay, so this process is often done with CT images. Okay, CT images are typically 12-bit images, 12 bits. So which means that they have 4096 values, right? 0 to 4095. This might be a very wide dynamic range wherein you might not be able to see very good contrast between, let's say, lesion or a tumor and background, a small tumor and a background. So you might want to map this into a slightly smaller range. Maybe you want to go to 0 to 255. So this is 8-bit range, right, where maybe you get better contrast. Okay. So this is one way of doing the transformation. Now, once again, this Fmin and Fmax are not necessarily need not come from the maximum and minimum values in an image. So the maximum and minimum values in a given image might not be meaningful. So you are also allowed to set your own, instead of Fmin and Fmax, instead of Fmin, you can go to Wmin, and instead of Fmax, you can go to Wmax. Okay, and because in the original image F, anything less than Wmin might not be meaningful. It could be some artifact, some error. Anything greater than Wmax might not be meaningful also. So when you do this kind of mapping, then you have to make sure you do a thresholding operation also. Find out all the pixel values less than Wmin and then turn them into Imin, which is what is here. Then find out all the pixel values greater than Wmax and find out and set it to Imax, right? But of course there is some conditions here, which is basically you want to make sure that Wmin and Wmax are within the range Imin and Imax. Okay, that's one other condition from which then you can map easily. Okay, so again there are variations of this. So this is the simplest version and often done. So it's called the window and level, often done on CT images. So this is one of the most simplest contrast enhancements, and you will end up doing this often. So for instance, even if you are, let's say, doing deep learning, right, and you have a bunch of CT volumes to process, so it will be nice before you provide these CT images as inputs to a neural network, a CNN for instance, in order to have an outcome, you might want to do the window and level on these images. So one of the strategies that people often use is to have an ensemble of networks, wherein each network has an input adjusted to a different window and level. Okay, so that it highlights different anatomies or structures of interest. So this is a commonly used trick. Okay, so that's all we have for contrast enhancement. So in the next video we will look at other techniques. Thank you.